When we last saw Nur and Blur, they had just gotten the results from the first 3 weeks' worth of data from monitoring their research subject Phil. Now it's the day after, and they're about to start their weekly team meeting to discuss how their research is going. Blur is especially excited about the data and the new technology they're using to gather it.
I just love the new Brainulator 8000. It's such a relief not to have to use the old Probe King 4000.
We got some great results yesterday, but some of the data, especially the data about the cerebral cortex, was inconclusive. I think we should monitor the subject around the clock and enable the thought scan. Then maybe we can make sense of the cerebral cortex.
There were nods around the table. The cerebral cortex is the largest part of the human brain that surrounds most of the other brain structures. From the data analysis, it appeared that the cerebral cortex was responsible for quite a variety of functions and many complex thinking processes, which made the data hard to sort out and get conclusive answers from. Nur and his group decided to divide the cerebral cortex up into 4 different parts, based on what appeared to be naturally occurring dividing lines in the brain. They called these parts the temporal lobe, the frontal lobe, the parietal lobe, and the occipital lobe. Hopefully, continuous thought monitoring and dividing the cortex up into 4 parts would help make some sense of its functions. So not more than a couple of hours later, Blur was in the control room, monitoring what Phil saw, heard, felt, and thought. It was a Thursday night, and Phil was searching around his house for something. Blur could see from his thoughts that Phil was trying to remember where he put something, a piece of paper that he had written a number on. Blur could also see that the temporal lobe of the cerebral cortex, or the lobe in the lower central part of the cerebral cortex, was showing lots of activity. Then Phil remembered that he had left the piece of paper in his car. He went to the car and retrieved the paper, and the activity in the temporal lobe came back down to normal levels. Blur noted the time and then entered an observation into the computer. Temporal lobe activity associated with memory. Now Phil had picked up the phone and dialed a number. When he started talking on the phone, Blur noticed another increase in brain activity in the temporal lobe, as well as an increase in brain activity in the frontal lobe, or the forward region of the cerebral cortex. In fact, it actually looked like the frontal lobe had more activity when Phil was talking, and the temporal lobe had more activity when he was listening. Blur made some more notes in the computer. Temporal lobe activity associated with hearing and language comprehension. Frontal lobe activity associated with speech. Phil spent most of the night on the phone and then went to bed. But Blur wasn't tired. In fact, he had an idea about how to test complex human brain functions. He beamed himself into Phil's garage and went to work on his car. First he slashed Phil's tire. Then he disconnected the battery. Satisfied that he had created a good test, Blur beamed back to the ship and waited for Phil to wake up and discover his handiwork. The next morning, Phil got in his car to drive to work without noticing the slashed tire, but the car wouldn't start. He tried again and again, but still nothing. Frustrated, Phil slammed his fist against the steering wheel, got out of the car, and slammed the door. He went to kick the tire and realized that it was flat, which just upset him more. Meanwhile, Blur couldn't have been happier. He had generated a major emotional response in Phil, and that response was corresponding with an increase in brain activity in the frontal lobe. He made another note in the computer. Frontal lobe activity associated with emotional outburst. Phil began to calm down and started thinking about what he should do next. Blur noticed something interesting. As Phil calmed down and he started planning his next move, a different part of the frontal lobe started showing more activity. Phil popped the hood and looked around. He noticed that the battery was disconnected and hooked it back up. Then he went to work changing the tire. Again, Blur noticed a new area of the frontal lobe was being stimulated, as well as a portion of the parietal lobe, or the top central lobe of the cerebral cortex. He made more notes in the computer. Frontal lobe activity associated with planning and motor function. Parietal lobe activity associated with motor function. The rest of Phil's day was uneventful, filled with lots of everyday functions and stimulation of multiple areas of the brain that the computer was better suited to sorting out than Blur was. But that evening was a different story, because Phil had a date. Like a gentleman, Phil opened the door for his date, and after she got inside, he closed the door, trying to look cool as he did it. But this was just not his day. Poor Phil shut the door on his own hand. Blur noticed something really interesting now. There was a sudden burst of activity in a localized area of Phil's parietal lobe, but only on the right side, even though it was Phil's left hand that had been slammed in the door. Blur double-checked to make sure, and yes, Phil's left hand was in pain, but it was the right side of the parietal lobe that was stimulated. So Blur made a note: parietal lobe activity associated with pain, but on opposite side of the body from the stimulus. Phil assured his date that he was fine. He took out the bottle of wine and put his still aching hand into the bucket. The ice water was very cold, but it dulled the pain. His date laughed, but Phil figured it could be worse. At least she seemed to be having a good time. Meanwhile, Blur noticed that the same exact area of the parietal lobe that had been stimulated when Phil slammed his hand in the door was now being stimulated by his hands sensing the cold water. And again, the stimulation was on the opposite side of the brain from the hand feeling the sensation. He made another note: parietal lobe activity associated with temperature, but on opposite side of the body from the stimulus. The rest of the dinner passed without incident, and then it was time for the check. Phil started figuring out the tip. He wanted to make sure that he didn't leave too little for the waiter and look like he was cheap, but he also didn't want to spend more than he had to, so it was time to do a quick calculation. Blur noticed that as Phil did his calculation, yet another region of the parietal lobe was being stimulated, so again he made a note: parietal lobe activity associated with mathematics. After dinner, Phil took his date to the Modern Art Museum. He figured taking his date to a museum would make him look cultured, and taking her to a modern art museum would make him also seem cool and knowledgeable about current trends. Neither of these was actually the case. He just liked looking at paintings. After all, that's what they were there for, right? Blur noticed that while in the museum, Phil's occipital lobe, or the lobe located at the very back of the cerebral cortex, was consistently being stimulated far more than any of the other lobes of the cortex. He also noticed that Phil wasn't really thinking about much at all. He was just taking in all of the visual cues around him and enjoying the scenery. So Blur made another note: occipital lobe activity associated with processing visual information. The museum was closing, so Blur decided to call it a night. He thought that he had enough now to assign at least 1 or 2 functions to each lobe of the cortex, and besides, everything was closing, so there really wasn't much more that could happen on this date. At the next team meeting, Blur presented his results to Nur and the rest of the research team.
Through careful observation and by presenting a challenge for the research subject to overcome, I have been able to map several functions to the 4 lobes of the cerebral cortex. The temporal lobe is the lobe in the lower central part of the cerebral cortex, located here, and it appears to be important for memory, hearing, and language comprehension. The frontal lobe is the forward region of the cerebral cortex, located here. It appears to be important for speech, emotions, planning, and motor function. The parietal lobe is the top central lobe of the cerebral cortex, located here. It appears to be important for motor function and integrating senses like pain, touch, and temperature. And finally, the occipital lobe is the lobe located at the very back of the cerebral cortex right here. It appears to be important for processing visual information.